reason. So you can say, wait a minute. Why do I need this notation, a to negative n, of this fraction? What's the big deal? Well, this is a condensed way of writing this.
Right.
Now you can say, why do I need a radical? I can only use this. Why do I need to even think of radicals? Because sometimes this is a more convenient notation, and I have to be able to toggle between the two of them. Like here, from here, here, from here, here. The same thing. When I see a radical, I know it's an exponential notation with a fractional exponent. When I see a fractional exponent on a base, I know it's basically a radical. So this is very powerful to be able to go from this to this, and the same thing here. This is a much easier situation than this. But being able to toggle between these two is very powerful. Because when you get to calculus, I'm having terrible difficulties with my calculus class. They don't understand how to differentiate this because they cannot change it into this. So differentiation is a totally different world. But what I'm saying is they're missing this connection, and they don't understand how to change this into this in order to do something else, because this is more convenient notation on certain things, but this is a more convenient notation on other things. Okay, so please understand, any radical is equivalent to an exponential notation with a fractional exponent. If the power is not a fraction, we are not dealing with a radical. Only when the power is a fraction, then we are dealing with a radical, and vice versa. Very powerful. Okay, so of course it's 6.8. Let's take a look. Okay, so the same idea. So the explanation here is because the power is 2 over 2. So the square root of 15m, everything squared, they should tell us that m is greater than or equal to 0, because otherwise this is not real. But they're not saying that. Fine. So remember, this is 15m to power 2 over index 2. So what will that be? Yes, that's how I get the 15m. So this is something similar to, once you see it, you cannot unsee it. If you remember, one of the things that I hope I taught you and I embedded this in your system is x over 2 is the same with 1/2 x. We have to be able to quickly see from left to right and from right to left, because sometimes this is more important or better than this. It's the same idea, to be able to see 2 over 2. Okay, moving on.
So for 15m squared, you wouldn't use the absolute value for the m?
So that's what I was saying. I should be using the absolute value, because that's why I said, if they say this, then I don't need to.
Okay.
If they don't say this, then I have to.
Then you need to.
It's a very good point. That's why I said from the beginning, so I don't mess with the absolute value. They should have said that. So do they have the absolute? Yes, they do have the absolute value. I'm very curious to see. Because they should, let's see. Oh. Okay.
Curious if you put it without the absolute value, if it would accept it.
Well, that's what I was saying. They should have said m greater than or equal to. It should not take it if they didn't say it. It should not take it without the absolute value. That's why I put the m, because I wasn't emphasizing the absolute value in that exercise. That's why I said they should. See? Okay, so let's explain this again. Or it's about time to explain this. Okay, so the square root of x squared should be x raised to 2 over 2, right? 2 over 2 should be x. This is true only if x is greater than or equal to 0. But look what happens if x is negative. Let's suppose x is negative 3. I replace here negative 3. I replace here negative 3. And now it's already wrong. So this is correct only if x is greater than or equal to 0. If it's not greater than or equal to 0, it can be, if it can be anything, then we have to write the absolute value on x. For x in everything. If x can be anything, then I have to use the absolute value. If x has to be greater, I'm told that x is greater than or equal to 0, I don't need the absolute value. The absolute value are redundant. The symbol, the two bars are redundant if I know that x is greater than or equal to 0. And yes, it's considered incorrect if I put them and I'm already told x is greater than or equal to 0. So the square root of x squared is the absolute value of x if there is no indication, meaning if x can be any real number. Now, if I have the square root of x to the 4th, 4 divided by 2 is x squared. Please do not put the absolute value on x squared. There is never a need to put the absolute value on x squared, because x squared is always positive no matter what. But yes, there is a need to put the absolute value on x, or the square root of x to the 6th. This is x to the 3rd. X to the 3rd could be positive or negative, so therefore I need the absolute value on x to the 3rd. But not on x squared, not on x to the 4th, not on x to the 6th. Because the even power creates a positive number no matter what. Good. So now we reach the next example, which is a very good one. So this is the square root of x plus 16. And this is page 9. So the square root of x plus 16, everything squared. Indeed, 2 over 2 is 1. But because x plus 16 could be negative if x is negative 20, I am forced to put the absolute value on x plus 16. Okay? There is no point, this will be a mistake, to, let's say, you decide, oh, I can square this. That would be terrible. X squared plus 2 times the first times the second plus the second term squared. This is, what is 16 squared? Yes. So 196. This will be terrible. Correct, but terrible, because I can simplify. It has 3 terms under the radical. I'm stuck forever. I can only simplify if it's factored. I cannot simplify if I have terms. I have no rule for square roots of terms. Square root of terms. I get stuck. But if it's a product, I can do something maybe. If it's a ratio, maybe I can do something. But if it's a sum of terms or difference of terms, I'm done. Nothing. I cannot do anything. So therefore, we never expand. So in this case, it's already factored. 2 over 2 is 1. But because the answer could be negative, I have to use absolute value bars. If the answer were x plus 16, everything to the 4th power, I didn't need to. So this is x plus 16. Do not fall into the trap of taking the square root of 16 or who knows what else. It's not possible. Good. How will you write the answer for this?
Absolute value of 3x plus 6.
That's it. An absolute value of 3x plus 6. Simplify the expression. Will you write the square root of 16 plus the square root of 9?
No.
No, because
Combine
it's a sum and you're not allowed to separate the radical if it's
Oh,
a
okay.
sum or a difference. But yes, 16 plus 9 is 25. And now the square root of 25 is,
5.
that's it. That is allowed. Good. Oh, yes. What about the square root of 49 plus the square root of 64? You cannot condense it. You can simplify each individually, though.
7 plus 8.
Exactly. 7 plus 8 is 15. So you
Okay.
punch in 15 and you're done. Good. Moving on. Now, you have to apply the power. You can say power? What do you mean by power? Yeah, because this is a power. What power? 1/2. So by the order of operations, I have to perform the power first.
So 4 times 3.
Exactly. So I determine the power. I apply the power first because any radical is a power. It's a fractional power, but it's a power. So I have to apply the power first, and then I get the answer and then multiply by whatever I have in front. Any questions? Okay. So this will be simply 12, and we are moving on. The same thing here. Can anyone give us the answer? You do the power, you perform the power first, and then you multiply the answer by -6.
-6 times 8.
Correct.
So -48.
Exactly. If you manage to remember that any radical is a power, you're performing a leap.
Do that.
Yes, you're performing a leap forward, not a pass or a step forward, okay? So 8, the square root of 25 over 64 minus the square root of 100. Perfect. We are allowed to separate the square root of 25 and 64 because they are both in positive numbers, and we can take the square root. So we have 8,
So 5 and 8.
5 divided by 8 minus 10. So we performed all powers. The square root of 25, which is a power, the square root of 64, which is a power, the square root of 100. Of course, we will simplify. Say it again.
It looked like the 8 was in the index, not to the left of it.
Not possible.
Okay.
But let's take a look. So it's up. Yes, you're right. It looks like it. Yes. Yeah, they should have. So that's why what I do, I would have written it like this.
Yeah.
But you're right. So 5 minus 10 is -5. Yes, you're right. So the cube root should be, it looks weird, but it is in front. So they should write it totally differently. So the answer is -5. And we move on. Really?
You accidentally clicked B.
I clicked B.
Click A again. Yeah, I don't know how that happened. Now press enter.
Oh,
Yeah.
sorry. Good, let's work on this one.
Yes, please.
So the square root, -9 squared, minus 6 times 5 times 9. You cannot take anything outside of the root, of the square root, because we have terms. We can only fully simplify inside and then hope for the best. The square root of -9, I'm sorry, Negative 9 squared, that is 81 indeed. Minus, here we have to multiply. So I like to multiply these two because I get 30. And 30 times 9.
270.
Good. And now I should already stop. Why I should stop?
Those are terms.
Correct. But why should I stop? Because
Yeah,
the answer under the square root will be,
A negative.
yeah, I don't need to
Which is
count.
imaginary.
Not a real number.
Yep, and I'm done. I don't need to do anything else. Good. So let's simplify this expression.
Ooh, this one looks intimidating.
So negative 1 plus 2 times negative 1. Negative 1 squared minus 8 times 3 times negative 2. This is a good example because this is the quadratic formula. We haven't discussed it yet, so you'll see it. Okay. So we have negative outside, and in parentheses negative 1, and then plus. And then we have the square root, and then negative 1 squared minus 8 times 3 times negative 2. Everything divided by 2 times negative 1. Here's what I recommend. Of course, the denominator is very clear. There is nothing special about it. Now the numerator. The opposite of negative 1 is definitely 1, and then I continue. Now I copy the square root. I have to deal with the power first, but negative 1 squared is 1. Now notice that negative 8 times 3 times negative 2, this will turn positive.
48.
Yes, very good, 48. Do not try to take the square root of 1 and the square root of 48. That would be a terrible mistake. It's like simplifying terms, right? So this is 1 plus the square root of 49 divided by negative 2. The power is next, which means 1 plus.
So
Very good. Divided by negative 2. So the top is 8, the bottom is negative 2, so the answer is negative 4. They're trying to throw us off. Good. Okay. So let's work on this. Let's take 1 minute and work on this. 7 minus 3 squared plus 4 minus 1 squared. Before you start, can I write the square root of 7 minus 3 squared, which is 7 minus 3, plus the square root of 4 minus 1 squared, which is 4 minus 1?
no, because they're terms.
Thank you. Never. Because they are terms. They're added. We cannot separate a radical. Thank you. We cannot separate a radical into 2 or more radicals if the quantity under the radical is a sum of terms or a difference of terms, or a difference of quantities or sum of quantities. They have to be factors. But by the order of operations, we have to perform the inside and square it. So 7 minus 3 and then squared.
16.
Perfect. And then 4 minus 1 and then squared.
9.
Now I can perform the inside, which is the square root of 25. So then the answer is 5. Very good. And then the answer is 5, and we move on. Good, a good one. So the square root of 5 times the square root of 25.
5.
Yes. So first we have to start inside, and we get this to be 5. So then we have the square root of 5 times 5, which is indeed 25, which is indeed 5. Good. Almost there. Okay. Consider the expression, very good example. Let's take a look. So we have negative the square root of negative a. So decide whether it is positive, negative, 0, or not a real number. If a is a positive number, I'm in trouble. Because I cannot take the square root of a negative number. So if a is positive, decide whether the square root of negative a is positive, negative, 0, or not a real number when a is positive. Which one is correct?
Not real.
Exactly. So if a is positive and I multiply by negative 1, I end up having a negative quantity under the square root. So a negative quantity under the square root is not possible. The negative quantity under the cube root is, but not under an even root. Good. Now, the negative square root of negative a is positive if a is less than 0. If a is negative, I will multiply by a negative number, and all of a sudden I have a positive number under the square root. Fine, it will be a positive number, but there is a minus in front.
It turns negative.
Yes, indeed.
You'll flip-flop the negative.
Yes. So the square root of negative a with negative, it's a negative number, correct? So now, if a is 0, the square root of 0 is 0. 0 times negative 1 is still 0. So the square root negative the square root of negative a is 0 when a is 0. Is it clear? Good. Last one. Oh, I thought there was, okay. By using replacement values for a and b, show that this does not equal a plus b. Okay, so they want us to use 2 and 3. Perfect. Here's the explanation. Very important rule. The square root of 2 squared plus 3 squared does not equal 2 plus 3. Because I'm not allowed to take the square root of a term plus the square root of another term. And here's the reason why. The square root of 2 squared plus 3 squared is the square root of 4 plus 9, which is the square root of 13, which does not equal 5.